So we're going to go to our last question of the day, which is also from those of you guys who did indeed send us your questions. So if you want us to feature you, send questions, guys. Send them. We are waiting for them. Right. So let's go and see what this one is all about. It reads as follows. In the diagram below, circle A, B, and C touch one another. Okay, very interesting. They touch one another, a bad thing nowadays because of Corona. You guys can't keep touching each other's hands. Remember to stay safe, stay safe. But in this case, the circles can touch each other. Right. C is on the same vertical line as A. And AC equals to 3 units. Very important. Let me just put that here on the sketch because I might forget very, very key information. Remember, like I say, you always need to analyze the love letter before you come to the diagram. That will help you a lot in terms of trying to answer the questions that you have in front of you. Right. Okay, and then we're told that the length of AB is actually 6 units. Okay, this is simply equal to 6 units. Very, very important. Okay, cool. Now the equation of the circle center A is given by x minus 2 squared plus y plus 1 squared equals to 4. Right. Now from that, what can we harvest from this? What can we harvest from what you're looking at? Well, the coordinates of the center, we know for a fact that the center, which is in this case point A, we're told that the coordinates have to be 2 and minus 1. And the radius of this circle has to be exactly equal to 2 because what you are looking at there is r squared. Since this equation of the circle is in the form x minus a squared plus y minus b squared equals r squared. So the center is that 2 and that minus 1 from plus 1 there. The signs change all the time. And then the radius is just the square root of the number you're looking at there on the far right. This is your circle written in standard form. So now I can harvest those two pieces of information as far as the circle centered O is concerned. Right. Now the examiner is asking you to write down the equation of the circle center C if AC is parallel to the y-axis. Right. Now we want you to find the equation of this circle here. Now the equation of any circle, beautiful people, any circle in the world for that matter, is x minus a squared plus y minus b squared is equal to r squared. Now what you need to worry about is the coordinates of the center as well as the length of the radius. Right. But now see what this is actually going to help us with. We know for a fact so far that the radius of the circle centered at point A, according to what we just analyzed in the love letter there, has to be exactly equal to 2. That means that leaves us with exactly a length of 1 for the circle that is centered at C, so that when you add both of them, you're going to simply have a length of exactly 3 as we were given in the love letter. Right. Now that means I've got my R there. That has to be 1. There's no two ways about it because you need 1 and 2 to get a length of exactly equal to 3. So I'm going to put my R there as 1. So I'm going to say, okay, that has to be 1 with a square. Now I'm worried about the coordinates of the center, guys. I'm worried about the coordinates of the center. Now here's something very, very crucial. You were told that that line AC is parallel to the y-axis. Now when two lines are parallel like this, it means that whatever the x value we have at the top is the same anywhere on that particular straight line. So the x value at A will be the same as the x value at point at point C, because C lies directly below point A. So keep that in mind. They've got the same x value because they are parallel to each other. So let's come and check what the story is. We did analyze from that love letter at the top there, according to that equation, that the x value at A is simply positive 2. That means anything that is below that point A will have the same x value as point A, which means at point C, the coordinates of C are simply going to be 2 and something else. Right. Now the y coordinate is very funny. Why? Because if you check point A here, we know that point A is lying at a y value of exactly -1. That's what the story is according to the equation that was handed out to us. The y coordinate is there. There's the y coordinate of A. It's actually -1 thanks to the equation of that circle. Now if you are at -1 and you must move 3 spaces going down, you are moving, you'll go to -2, -3, and then you will end up at -4. So that means that point C is actually lying at a y value of exactly -4 because you're going down 3 units according to the length of AC. And that is actually going to leave us at -4. Now I'm going to take those as the coordinates of the center and plug them in this equation. I'll have x minus 2 with a square, and I'll have y minus 4, then it's going to be plus 4 with a square. And that, beautiful people, gives me the equation of the circle that is centered at the origin. It's easy. That's why they say to you, write down. It means there's not a lot of hustling happening when you're trying to figure out the solution to that one. Okay, cool. Now I'm going to go to the follow-up question that says, write down the expression in terms of theta for the area of triangle ABC. Okay, triangle ABC. Let's go and check it out. All right. Area of triangle ABC. There's A, there's point B, there's point C. What do we know so far? Well, I think you guys must know by now that there are two ways of working out the area of a circle, right? And I mean the area of a triangle. You can, if a triangle has got one side that is perpendicular to the other one, you can use half base times height. But if you don't have any two lines that are perpendicular to each other in that particular triangle, then you have to use a general formula for calculating the area of a circle, and that is half one side times the other side sine of the angle included. Right? That is the formula that you can get if you're checking from your trigonometry. Again, you see trig is playing a big role in this. It's trying to help you to figure out what is going on as far as this is concerned. So I'm going to go away and say, okay, fine. I want to find the area of a triangle that doesn't have two lines that are perpendicular. So I need the two sides and the angle included between those two sides. It's going to be half of one side times one side sine of the included angle between them. Right? So let's see what the story is going to be. Right, beautiful stuff. So we know so far that that triangle they're telling us about looks exactly like this. And then it's got A here, it's got, I think, B here, yes, it's got C here. This is 3, and then we know that this one is actually equal to 6. In the middle, we've got an angle of theta. So to work out the area of this, I'm going to just say area of triangle ABC is half of one side sine of the angle between. So one side there is 3, the other side there is 6. The angle between them is theta. So this simply amounts to half of 6 is 3. That's actually 9 sine of theta. They said they want it in terms of theta. In terms of theta means theta must be one of the things that you have in your answer. So this will give us the solution to this question. Right. And then the other question on this, this is actually a beautiful question. It's touching on analytical geometry and trigonometry at the same time. What value of theta, for theta is the element of 0 degrees to 180, will maximize the area of this triangle, right? What value of theta will maximize the area of this triangle? Now, once you start seeing examiners talking about maximizing, right, in trig-related questions, this is not a trig question, it's in analytical geometry, but it's trig-related, very, very related to trigonometry. You need to think about the graphs. Our area came out as area equals to 9 sine of theta. Now, if you think about the sine graph, think about the sine graph. The sine graph between 0 and 180 looks like this. This is how the sine graph simply looks, right? And you will agree with me. You'll agree with me that according to what we are sitting with here, the maximum value of any sine occurs at 90 degrees. And that happens to give you a value of 1. At 90 degrees, you're going to have a value of 1. Again, at 180, will be at 0. And then we don't have to go all the way to 360 because they just said between 0 and 90. So I can actually remove this part that takes us to 360 because we want to focus only between that and 180 degrees. So the maximum value will happen when the angle is 90 degrees. So the answer to this is just simply going to be theta equals to 90 degrees. And there's no complications at all. So thank you very, very much for sending these questions. This is a great demonstration of what really happens when you understand what is going on in math. You need to integrate your analytical geometry together with your Euclidean as well as your trigonometry. So don't forget about those concepts. They're very, very key and they play a big, big role when you're working with your trigonometry.